Alright guys, welcome to part 2, organic chemistry legal discussion. Alright guys, looking at organic chemistry. Okay, so I think all the school started right. Okay, jump. So guys, what we have first is empirical formula. So guys, for empirical formula, right, we always tell you our simplest whole number ratio, yeah. So for example, right, a propene is gonna be a C3H6. Empirical formula is CH2, yeah. That is the simplest one. Okay. And next. So the second one, the next one that we have is a molecular formula. So molecular will always tell us the actual, yeah. Okay, after that, we have structural formula. Guys, structural formula will tell us how the atoms are arranged. Like how is it being arranged? Okay, so for example, you see you have a CH3, like a propene, right? Is a CH3, CH, CH2. That is the structural formula of a propene. Okay, and next, let's say if you draw it out, this one, right? That we call it as a displayed formula. So when you draw it out, it turns into a displayed formula. And finally, guys, we have the zigzag known as a skeletal formula. So skeletal formula, right? Each end that you're looking at are a carbon, Hassan. So carbon with all the hydrogen removed, you see, 1, 2, 3 hydrogen, 1, 2, 3 hydrogen. All the hydrogen removed. So carbon and hydrogen removed. That we call it as a skeletal formula, yeah. Clear? I can't download chapter 30 notes. Why cannot download chapter 30 notes? I send it here to you. Okay, please download it. And page 2, let's go. Can Alright guys, now let's look at second page. Alright guys, now I'll teach you how to draw skeletal formula for each. So starting from butane, guys, formula for butane is a C4H10, right? So guys, we're gonna draw 4 carbon now. 1, 2, 3, 4. That's it. So guys, you see you have a 4 carbon. 1, 2, 3, 4. Done. That's a butane. Alright, next, please draw a pen 2 in. So how to draw a pen 2 in? Pen is 5 carbon. So draw 5 carbon first. 1, 2, 3, 4. And a 5. 1, 2, 3, 4, 5. 有 Chagi You grab. And double bond pen 2. Okay, so first carbon, second carbon. So double bond here. There you go. Please write down, guys. Try the third, fourth, fifth, sixth. Let's go. Give me a second. It's going to crash. Alright, guys, let's go. Ethanol, how to draw? 2 carbon, right? So we're gonna do 1, 2. That's the 2 carbon already. Then link to a OH. Okay, that's it. So guys, you see, it's a CCOH. This is not a C. Get me or not? It's a CC2OH. Propanol acid, 3 carbon. Let's draw 3 carbon. 1, 2, 3. Let's see, 2 lines, 3 carbon now, 1, 2, 3. Okay, then carboxylic acid will have a double bond O, OH, done. Alright, next, guys, we have a 2,4-dichloropentane. So, guys, pentane is going to be 5 carbon, 1, 2, 3, 4, and a 5. You see, right, guys, 1, 2, 3, 4, 5. And, guys, you have 2 chlorine, so which means 1 Cl on the second position, second Cl on the fourth position. Done. So fun. Know how to draw, yeah? Last one, go. Alright, finally, try bromo hex 1 in. Hex is 6 carbon. So 1, 2, 3, 4. And a 5, 6. So guys, you have 1, 2, 3, 4, 5, 6. So guys, they say 1 in, which means double bond in the first and second position. Okay, 1, 3, 5 tri-bromo, which means I have a bromo here. Okay, 1, 2, 3 bromo, 5 bromo is here. So guys, you see 1, 2, 3 bromo, 4, 5 bromo, done. Can I see? Any question? Know how to draw your skeleton? So guys, again, okay, throughout the lesson, I will grind you guys and train you guys to do skeleton, I want you guys to do skeleton with me, okay? Because eventually, okay, I'm gonna teach you guys to draw skeleton and I will not show any structural, okay? So the goal is to do everything in skeleton. Clear? Okay, please share your answer. We are moving on to page 4. Skip page 3. Alright guys, now let's look at how do you name your organic compound. So to name your organic compound 1 to 10, like math, F, prop, build, I think you guys should know how to name it. And methyl, ethyl, propyl, butyl, pentyl. Okay, so this also you should be able to know how to name it. So side group, Cl is known as chloro, yeah, Br is known as bromo. The only side group that you guys need to memorize is OH. So let's say OH is not an alcohol, then we call it as hydroxy. Okay, so guys, if you have 4 side group, we call it as tetra. Okay, 4 side group is known as tetra. That's it. Alright guys, next. So using my step-by-step guide, so first please name and identify the longest carbon, So I'll teach you guys how to do it. So please identify the longest carbon chain and name all the side group. Please name all the side group. And always use the lowest number possible to name the side group. That's it. Alright, then after that, page 5. 4, 5, nonsense. I'll teach you guys how to do later. Okay, guys, next. You see, right, when you see a dash, okay, so a dash, right, is always used in between an alphabet and a number, So dash is always in between alphabet number, we use dash. Guys, for example, we have 2 bromo, 3 iodo. So a dash is always in between a number and an alphabet. Okay, a comma, on the other hand, is between 2 numbers. So for example, we have 1,1 dimethyl. Okay, we have 2, 3, 5 trichloro. That's it. Okay, all good. Alright guys, next. Let's look at this question. Alright guys, I'll show you how to get the naming starting from the first one. So please highlight the longest. Ding, 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 ding. These are my longest. Ding, 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 ding. Alright guys, first is always to identify your longest. After getting your longest, then name the carbon accordingly. 1, 2, 3, 4, 5, 6. So you have 6 carbon. We call it as hexane. So name the longest first, yeah. That's your first step. After naming the longest, second step is to name the side group. So side group, please circle it. CH3 is known as a methyl. C2H5 is known as an ethyl. So we have a methyl and we also have an ethyl. Okay, after naming the side group, next is choose the smallest number. So the smallest number can be from left to right or right to left. So we're going to try from left to right. 1, 2, 3, 4, 5, 6. Or right to left. 1, 2, 3, 4, 5, 6. Like, baby, let's look at which one is my smallest, yeah. So methyl is 2, 5. Ethyl is 4, 3. So do you see that 2, 5 is smaller than 2, 4 is smaller than 5, 3? Can see, right? Sure, can we do like go up and the end, then ethyl will be on 1. Can we go up at the end, like how, like that? Can also. 1, 2, 3, 4, 5, 6. Then this is still an ethyl. Yeah, can. It doesn't matter. But okay, so yeah, it can be done. So guys, you see, which means going this way, going to the right, this is my smallest, can see or not? Because 2, 5, because it's a 2, 5, 2, 4 versus a 3, 5, 2, 4 is smaller. Alright, then guys, finally, to name it alphabetically order first, ethyl will come first. So it's 4 ethyl and a 3 methyl hexane, done. Okay, so the first one we call it as 4 ethyl, 3 methyl hexane. Done. Second. Hey. 2, 2, 2, what? 3, bro. 2. Thank you, thank you, thank you. My bad.
Go other way around also.
Go other way around, it's gonna be a 3 ethyl and 5 methyl. 3, 5 is bigger than 2, 4. So we choose the smaller one, get me?
2 methyl, 4 ethyl, same.
Where got 2 methyl and 4 methyl? You can only choose one direction to go.
Oh, 2 methyl, 4 ethyl.
2 methyl, 4 ethyl.
Right.
Wait. I wrote 4 ethyl, 2 methyl. Yeah. How can it be 4 ethyl? 1, 2, 3. How can it be 4? How can we be 2 ethyl? That is not 2.
No, 2.
2 methyl.
Yeah, 2.
Okay, 4 ethyl, 2 methyl. That's it. Okay, guys, Q2. Please get me the name now. Alright, guys, let me answer yet.
How come this one carbon have 5 bonds?
How come carbon has 5 bonds? Which carbon has 5 bonds?
CH3 one, CH3, CH3 one.
This one.
Yeah.
Where got 5 bond? 1, 2, 3, 4. Where you see 5?
The power H.
Huh?
The H.
Oh yeah, bro, that's the H, bro. Sorry. Yeah. Thank you for noticing the. Yeah, there's no H there. Wow, thank you. Oh, yo, so fast. Thank you so much. Wow, damn fast. I like you, man. All right, thank you so much. Yeah, you got the answer correctly. All right, guys, I already have one correct answer. Please send in your answer if you're done. Check for you. Four ethyl 3 dimethyl heptane. Thank you. Almost. 4 ethyl 3 dimethyl heptane. Almost. Thank you. So, guys, I think most of you guys almost, yeah, everyone almost get it right. Almost, just almost, but not bad. Well done. So, guys, we have 1, 2, 3, 4, 5, 6, 7. I would say going this way is the smallest. Okay, because going other way shouldn't be like no way you can get a smaller number. So 7 is a heptane. Write it down first. Then circle all the side group. What are the side group? Methyl, methyl, ethyl, correct. So E come first before M. Ethyl is on 4th position, so it's a 4 ethyl. And after that, you have methyl, methyl on the 3rd position, right? So we call it as 3,3 dimethyl. So guys, you have to tell me it's a 3 and a 3 and dimethyl because you have 2 methyl. Get me? That's it. 4 ethyl, 3,3 dimethyl heptane. Done. Thank you very much. All right, some of you guys get it right. Some of you guys near miss. Okay, good job. All right, guys, do the third one. Let's go. It's numbered for you already. Shouldn't be too hard, yeah. Okay, I have answer coming in. 2, 3, 5, try 4. Thank you, Bernice. You got it right. Okay, so long almost. Just a careless mistake. Check your answer again. It shouldn't be a ethyl, boy. That's not an ethyl. I don't see an ethyl. That's not an ethyl. Try again and see. Just a careless mistake. Okay, Alex, gotten the answer. Thank you, Alex. You got it right. Well done. Hi, thank you, Yongshin. You got it right. Well done. Gloria, numbering is not right. Your numbering is not quite right. It's just the numbering. All right, guys, let's go. I think done. So, guys, label for you guys already. You can go here, yeah. Okay, so that's it. So guys, why don't we go this way, right? Because this part is way too big already. You can't really name this part. Okay, so we prioritize a straighter chain first. So you have a 7, right? So 7 we call it as heptane. Alright then guys, circle the side group. Methyl, 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 propyl. Correct. So M before P. So we write methyl first. So it's gonna be 2, 3, 5 trimethyl, and 4 propyl, Heptane, done. Can know how to name, yeah? Fun, right? If you get a naming, very short one. Yeah, it's a propel. Thank you, Sun Long. You got it right. All right, guys, next. Let's go. All right, guys, for this part, right? Okay, so just highlight the ring. I just want you guys to highlight the ring. So, guys, when you see enclosed ring, yeah, okay, so this enclosed ring, right? Whenever you see enclosed ring, we call it as a cyclo. Okay, not cycle, but cyclo, yeah, cyclo. Okay, guys, this enclosed ring is made from three carbon, so we call it as propane. Okay, so we call this as a cyclopropane. And guys, you have a CH3, which is a methyl outside of the cycle ring. So we call it as a methyl cyclopropane. Done. Clear? That's it. Okay, guys, now we are so done. No need to say the position. No need to say the position. Because any position, it's going to be a position one. Don't need to say one methyl because there's no two methyl. You get me? Okay, you don't need to mention the position on one reason because there's no two methyl. It can only be a one methyl. Correct? So guys, all this we're going to skip. Don't need to do, don't need to do. And I want you guys to look at page 10. Yeah. Page 10, before it, give you guys 5 minutes break. Is that okay? 3 to 5 minutes break. I'm gonna go washroom. Okay, so 3 to 5 minutes break. Let's go. Okay, let's go. Okay, guys, now let's continue. All right, kid, right now let's look at a sigma and pi bond. Okay, guys, look at sigma and pi bond. Again, remember, sigma is a strong bond, pi bond is a weaker bond. Sigma is formed from direct overlapping, and each carbon can form up to 4 sigma bond. Why? Because you can share 4 electrons here at do, re, mi, fa. Correct. Okay, guys, next. By forming a single covalent bond, a carbon atom can gain a stable electronic configuration. A single covalent bond. Remember, every single covalent bond is always a sigma bond, yeah? Okay, so electron is in the sigma bond is found in between the nuclei. And guys, for any carbon that forms a 4 sigma, the shape is always tetrahedral. Remember that, yeah? And for any tetrahedral, bond angle is 109.5 degree. That's it. Okay. Okay, guys, now let's look at different type of hybridization, starting from sp3. Guys, for sp3 hybridized, right? Remember this, yeah? For sp3 hybridized, usually you have 4 sigma bond and 0 pi bond. Okay, for sp3, the characteristic is all single bond. And bond angle 109.5, shape tetrahedral. Done. Okay, so these are the property for sp3. All right, guys, what about for sp2? All right, guys, for sp2, it's going to be 3 sigma bond. Okay, or you will see 1 pi bond. This is when a pi bond starts appearing in sp2. So, guys, usually sp2, right, is when you see a double bond, yeah? And the bond angle is 120, trigonal planar. Done. All right, guys, next. Finally, we have SP. All right, guys, for SP hybridization, right? Okay, usually you have a 2 sigma bond and you have 2 pi. Okay, so for SP, right, it's for a triple bond. For example, like a C triple bond C, N triple bond N. Or it can be a 2 double bond. Okay, bond angle is linear 180 degree. That's it. Finally, guys, we have a pi bond. So, guys, for pi bond, remember a carbon can also form a pi bond, okay, between its atom in organic compound. All right, guys, in a double bond, how many sigma, how many pi? It's made up of 1 sigma, 1 pi. Oh my God. Okay, guys, triple bond, how many sigma, how many pi? Oh my gosh. Triple bond is 1 sigma, 2 pi. Get me? All right, so carbon atom involved in a double bond will each form 3 sigma bond. 3 sigma is sp2 hybridization, yeah. That's it. All right, guys, now I want you guys to look at next page. Okay, guys, you see, right, for a pi bond, okay, whenever you have a double bond, right, looking at a double bond, so double bond will always give a bond angle of 120 degrees. All right, guys, now let's move on to the next one. Go. Please fill this up. Yes. Hey, 18 is more reactive. 18 more polar, that's why it's more reactive. Can scroll a bit? Can.
18 has higher boiling point.
18 has higher boiling point. No, 18 has lower boiling point. All right, guys, let's go. So let's look at ethane. Okay, so if you were to draw ethane, right, it does look something like that, correct? CH3, CH3. So all sigma bond angle is 109.5. You can see there's no double bond, sp3 hybridized. Each carbon has 4 sigma. Clear. Okay. Okay, guys, next. What about ethene? Okay, look at ethene. Please tell me now. What's your answer? So for ethene, planar structure, bond angle of 120, correct or not? Hybridized, sp2. Each carbon has 3 sigma 1 pi. Guys, what is your 3 sigma 1 pi? 1, 2, 3 sigma. So always remember in the double bond, it's 1 sigma and 1 pi. Done. And guys, ethene is more reactive than ethane. Why? Because pi bond is easier to break. Okay? In ethene, there is a pi bond, and this pi bond is easier to break. Done. Okay, that's the reason.
So it's like electrons move further apart.
Huh? Electrons move further apart? No.
Iphone.
No. Pi bond is weaker bond. Alright, guys, please write it down. Once done, next. Alright, guys, next page. Okay, let's go. Look at this question, and I want you guys to start doing it right now. Answer? Done. Alright, guys, now A, B, C, D. Let's go. I need you guys to tell me the hybridization state. Scroll to ethane. Sorry, I just saw you scroll to ethane. Come. Alright, guys. First one, A, B, C, D. What's your answer? A is a sp, 2 hybridized, right? B, sp2 as well because of a double bond. C is sp hybridized, sp3 hybridized because all single bond. D is a sp hybridized, correct? Arrangement, sp2 is trigonal, planar. Bond angle is 120. That's it. Understand, yeah? Don't go and tell me, 90 degree, that's not a 90 degree, okay? Okay, sp3 is tetrahedral, 109.5. sp is linear, 180. Clear? Alright, guys, go. Second question. All right, guys, now let's go. Answer. How many sp3, guys? Anyone? Page 11 top part, can. Page 11 top part. Now go. I'm waiting for your answer, guys. Please tell me how many sigma, how many pi? 2, 3, 1. That's it. 2, 3, 1. Okay, guys. Any other answer? 2, 3, 1. All right, guys, if you cannot see the carbon, I'm going to put down the carbon for you guys so you can see where the carbon is located. That's it. All right, guys, let's go. So the first one, 4 sigma bond, or the single bond is definitely going to be sp3. Second one is a double bond. This sp2. Next one, let's look at it. This is a 2 double bond, which means there's 2 sigma, 2 pi. This is only possible for sp. Then single double bond is sp2. Single double bond is sp2. And single bond is sp3. So in total, that is 1, 2 sp3. Thank you. 1, 2, 3 sp2. Thank you. 1 sp. Thank you. Ooh, wow, nice. Well done. Thank you, Bernice. Lovely. Okay, well done. All right, guys, next. Draw how the orbital overlaps for a sigma bond in C and an N. So, guys, what you can do, you can draw an atom for N and draw an atom for C. This is representing the nucleus of carbon and neutron and nitrogen. Okay, and guys, for a sigma bond, it's always a direct overlapping. You can just draw an oval shape that circles around the C and N. That will be your sigma bond. So this shows a direct overlapping. Yeah, that's it. All right, guys, how to draw a pi bond? Pi bond is always above and below. Remember that. So you can draw 2 over that is located above and below. Done. Okay, guys, that's how you draw your sigma and pi bond, yeah? Sorry? Like a dot like that. No need. Done. Easy. All clear. What is the sideway overlapping? Yeah, this is the sideway overlapping. Sideway overlapping. See, I'm showing sideway overlapping. Just that I never show the orbital. Can see that? Okay, Okay, guys, one's done. Page 12 done. Page 13, let's go. All right, guys, next. What is isomer? Kid, come, isomer. What's isomer? Isomer is structure with same molecular formula, but different structural formula, yeah. Keyword, same molecular formula, different structural formula are known as structural isomer. All right, guys, in your AS, okay, you have 2 types of isomerism, which is structural isomerism and stereoisomerism. Okay, so structural is, okay, sort of done in your IG. So we have chain, positional, and functional. So we call it as PCF. Not PDF, but PCF. So P stands for positional isomerism, chain isomerism, functional group isomerism. Done. That's it. All right, guys, now. So in position isomerism, right? What is position isomerism? It's always the position of the side group or the functional group that is jumping around, yeah. Okay, it's always the position of your side group or functional group that varies. That we call it as position isomerism. That's it. All right, guys, next, let's continue. All right, kid, let's look at this. C3H6Cl2. All right, guys, I'm going to show you the first one, yeah. Okay, we're going to draw 3 carbon, 1, 2, 3. C3H6 already. Okay, then, guys, we're going to put in 2 Cl. First Cl, second Cl. So, guys, this is what we call it as. So, first and second Cl, we call this as a 1,2-dichloropropane. Alright, guys, go and swap your position of your chlorine and tell me what are the remaining isomer. Let's go. Okay, thank you. I have answer coming in, guys. We have how many in total? Guys, we can have a 1, 3. Well done. Apart from 1, 3, any other? 1, 1. Okay, that's a very good one. 1, 1. What else? Okay, 2, 2, and thank you. Okay, I see 2, 2. I'm happy. Alright, guys. Is 2, 3 your answer, guys? Guys, can it be a 2, 3? Yes or no? Yes, correct. Good, guys. Can never be a 2, 3. Don't draw a 2, 3. Why? Because 2, 3 is the same as a 1, 2, right? Okay, so 2, 3, if you count from right to left, it's a 1, 2, yeah? Clear. That is your positional isomerism. Clear? Alright, well done, guys. Next, let's move on to functional group isomerism. So guys, for functional group isomerism this time, we're gonna have different functional group present here. Okay, you have a different functional group present. Okay, a good example that we have, right, is alcohol and ether. So alcohol and ether, right, let me show you how to draw. So alcohol, I can draw this CC. Going to put all the H's here and put the OH here. So do you see that this is a function, alcohol functional group? We call this as an ethanol. All right, the second part, we have a dimethyl ether. So what's an ether, right? Okay, the functional group is in between the C. Like a COC, clash of clans. COC, ding ding. Okay, so COC, this we call it as a ether, but ether is not in the syllabus. But I just want you guys to know that this is a functional group isomerism. Okay, guys, please write it down. Ethan 1O or ethanol. There's no ethan 1O. Okay, so it's just ethanol. Because there's no ethan 2O. You get me? There's no ethan 2O. It's just ethanol. All right, guys, next. What do we have is functional group isomerism for carboxylic acid and ester. So, guys, a carboxylic acid and ester, right, they can also form a structural group isomerism, yeah. Okay, so guys, looking at carboxylic acid and ester, right, see, I'm going to draw a carboxylic acid with 3 carbon. Okay, so 1, 2, 3. And carboxylic acid functional group is a double bond O, OH, right? Remaining part, I can just put a H's. So guys, do you see a C3, H6, O2? Done. This, we call it as a propanoic acid. Functional group, that is our carboxylic acid, COOH. Okay, please write it down. Alright guys, can you draw an ester with 3 carbon? Do you guys remember how to draw ester? Okay, please show me ester with 3 carbon. I think most of you guys done in school already, right? Go. Any answer? Okay. So guys, for 3-carbon carboxylic acid, okay, done. But what about ester? I can draw a C, put a functional group here, double bond O, then connect back to a C. Put down all the hydrogen, deng, 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 deng. Alright guys, do you see this is my ester functional group? COO. And guys, how do you name ester, right? We always name from the alcohol end, which is here. So this is a methyl. Then we name the carboxylic acid end, ethanoate. That's it. Clear? Alright guys, last. Okay, I can also draw, this time I'm going to show you a skeletal, yeah. Okay, I can also draw a C double bond O, straight away connect to a O. Then connected to a 2 more carbon. Let's see one more time, guys. You see, it's going to be like C double bond O, connect to O, connect to a CH2, connect to a CH3. Okay, I'm showing you guys a skeletal this time. Okay, let's go. Alright guys, next. Please tell me what is the name given. You have 2 carbon connected to the alcohol end, so we call it as ethyl. And 1 carbon connected here, methanoate. That's it. Clear? Alright guys, next. Let's look at functional group isomerism for C4H8. So guys, functional group isomerism for C4H8, right? Let's look at the C4H8. This is basically alkene and a cyclohexane. It's not cyclohexane, cycloalkane. Alright guys, C4H8 could be build 1 in or build 2 in, it doesn't matter. Okay, so this is a build 1 in. If I were to draw a cycloalkane, right, it does look something like that. That is a cyclobutane. Done. Because you see 1, 2, 3, 4, 2 H's, everything is still a C4H8. Okay, do you see that they are a functional group? They are a functional group isomerism of one another. Let's go. Okay. And guys, finally, let's move on to the last one. We have chain isomerism. So kid, for chain isomerism, it's pretty easy. It's when you have a different, okay, so chain isomer differs in their structure of the carbon skeleton. So right now, the carbon skeleton is not the same anymore. Okay, so a good example is C4H10. All right, guys, you see, I can draw a C4H10 with just a straight chain. 1, 2, 3, 4. This we call it as a butane. I can also draw it a 3 chain. 1, 2, 3. Connect the third one here to turn into a Mercedes. This we call it as a propane, methyl, right? Or methyl propane. Sorry, methyl propane, not propane, methyl, bro. Okay, methyl propane. All right. 1, 2, 3, longest propane. 2, you have a methyl group present. All right, guys, do the next one for me and please name everything. Go. Uh, the C, pentane. Let's go for pentane. Okay, guys, please tell me how many isomers you have in total, including pentane. Aiyo! What kind of sorcery is this? You go and look for your longest, then you know where's your longest. Where's your longest? 1, 2, 3, 4. Longest 1, 2, 3, 4. It's a butane. 2 without. These two are the same. Oh, guys, please tell me how many isomers in total. Let's go. Dun, 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 dun. Okay, guys. Final answer, how many? 3, 2, 4, 5, 6. 6, 7. 1, 2. I only got 3. All right, guys. First one, pentane. 1, 2, 3, 4, 5. Name it. I will need you guys to put down the name. It's a pentane. Second, I'm going to reduce the carbon number by 1, which is a butane. And draw an additional link here, right? That will turn into a 1, 2, 3, 4. It's a methyl butane. Okay, so guys, you don't need to put a 2 methyl butane because methyl butane can only be a 2. Because if you put it here, this will automatically be a 2. Okay, no matter where you put it, it's automatically a 2. Get me? Okay, so it's just a methyl butane, or you put a 2 methyl butane also is fine. So which means 4 carbon no more, reduced to 3 carbon. So guys, remember, after that, you cannot put it anywhere at the corner. Because if you put it at the corner, so ding, 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 if you put it here, is it ding, ding, it's going to be 1, 2, 3, 4, 5, turn back to a pentane again. Then you don't do this. You put here, then it turn back to this one again. Or you put here, then it turn back into 1, 2, 3, 4, 2 methyl. It's the same thing again. So the only way that you can put the 2 extra carbon is on top and below on your second carbon. Correct. So your answer is a 2,2-dimethyl propane. Done. Is that right? Who are? Okay, guys, next, let's look at page 17. Page 17, we do it next week. And that will be all for class today because I cannot move on to page 17. This entire section is going to be a brand new one that will need about an hour. But not bad. Go achieve. Arrangement in space. Different spatial arrangement. Next week, we're going to do stereoisomer, yeah? Okay? So, guys, that will be all for the class today. I'm speed running some of the easy stuff. But this one is a hard stuff. We're gonna do it slowly next week. Okay, and that will be all for the class today. I'll see you guys next week, and adios.